Hello everybody and welcome to today's webinar. Today I'm joined by EuroSTAR tutorial speaker and keynote speaker Paco Hope, who will talk to you today about security testing. And the title of his webinar is Zen and the Art of Security Testing. If you have any questions for Paco, please type them into your questions field on your control panel. And at the end of the webinar, we'll go through as many of these questions as we can. And don't forget, you can type these questions at any point during the course of the webinar. So I'm going to hand you over to Paco now. Hello, Paco.
Hey, how are you?
Great.
All right. Thank you all for attending. I'm really pleased to see so many folks have joined in. Let me get my slides up for you. Right. So I want to talk to you today about Zen and the art of security testing. The idea being that I'm going to talk to you about how you can make a meaningful impact on security testing while doing largely the kinds of things you already do. I have spent a lot of time talking with and working with software testers over the years, and I realized that there's an awful lot of what they do in their day jobs that could have a huge positive impact on the security of software. And so this is a talk I put together largely to explain some of the things that I've been thinking about over the years. I'm hoping that the kind of thing you do for a living is functional or non-functional testing of software, that this is your career, and that you're looking to do more security testing in the testing that you already do. I mean, that's the topic, that's what we're going to cover. Before I go much farther, I'm going to do a brief just introduction to myself and my company and where I come from. I come from a consulting company called Cigital, and we do software security consulting right the way through the life cycle. So early on, requirements and user stories and inception kinds of activities, making software secure. We look at software architecture or design. We can look at source code and look for security bugs and vulnerabilities in source code, and right the way out to the testing and operations and penetration testing as well. I'm one of many security experts at Cigital. Lots of us have written books and speak at conferences and authored white papers and so on. We try very hard to get out and speak. To discuss me just a bit so you know where I come from and who I am, I've been doing the security consulting thing for about 13 years now. And I've done everything from source code to design reviews, risk analysis. I've helped firms put together security programs. And most of my clients are in sort of financial services like banking or investment banking. And I've worked on online gaming and gambling type things like slot machines. And I've also worked on online retail. In fact, I spend a lot of my days these days with online retail, and it's a lot of fun. Professionally, I work with ISC Squared a fair bit, and if you're familiar with the CISSP certification, it's one of the certifications that I have, but I also write the exam questions for that exam. So if you know somebody who has taken that exam, you can apologize to them on my behalf for how hard some of those questions are. And I've written a couple of books on security, both at the operating system level on FreeBSD and web security testing specifically. And I helped Gary write the software security book. I contributed chapter 8. Now, I got into looking at software testing probably 10 years ago. I went to my first STAR conference, and it was STAR East in the US. And thinking myself a pretty clever hotshot cowboy security guy, I thought I knew a lot about testing software. And what I came to discover at a conference full of people who do testing as a career, I discovered that, wow, these people are passionate and they're intelligent and they're doing a lot more than I gave them credit for in terms of professionally testing software. And in fact, I had a lot more to learn than I had to teach at that time. And so I realized that software testing is one of these parts of the development lifecycle that is really underutilized in terms of its potential contribution to security. And so I've spent a lot of time trying to bring the little bits of security testing I think are genuinely interesting and different into the regular software testing that's happening every day, all day. Let me give you the inspiration for what we're going to discuss. Years and years ago, I was in high school and had some study, I'm sure, of Zen or Buddhism or whatever it was. This quote at the time stuck with me, though I didn't understand it for a really long time. You know, before one studies Zen, the mountains are mountains, waters are waters. But after a first glimpse into the truth of Zen, well, the mountains are no longer mountains and the waters are no longer waters. And then after enlightenment, the mountains are again mountains and waters are again waters. And I think it was some time before I had any mastery of any particular field and I actually understood what this slide was actually saying. I think there's a parallel to security. You know, before we really start doing security testing, software is software, test cases are test cases. And once we start looking at security testing, things start to look different. And we think, oh, wait, you know, software's really not what I thought it was, and test cases are not what I thought it was. And once we reach some level of mastery with software, with testing, with security, software is again software, test cases are again test cases. It all comes back to being normal. That was the motivation, the metaphor that guides this whole webinar today. And we're going to cover, you know, a few little things. When we do functional testing versus, say, security testing, you know, we start with this notion of what the software ought to do, right? We can call it our user stories, or it can be a design spec, it can be whatever. And then there's, of course, the actual implementation, which never quite exactly matches. It's never quite perfect. And functional testing is going to be looking for the bits that we said we were going to do, but we didn't, right? The missing features or the missing functionality. And they're likewise going to be checking for boundaries and edge cases and corner cases that weren't anticipated during the implementation. From a security perspective, the stuff that we wrote that we didn't mean to write, or the functions and features that are behaving in ways we weren't really intending, those are all potential security vulnerabilities and potentially not covered by standard tests that we're going to run. And so the metaphor there too is, you know, from a security testing perspective, we have to think outside the box. We have to think about these little bits that weren't covered by the routine testing, by the happy path, by the standard implementation. So what we're going to cover in this webinar is some of we're going to go from, you know, theoretical down to practical. First talking about how we get security into user stories, into the test cases that we write at a sort of theoretical or almost philosophical level, and then move down to test cases that we actually have, test cases we already run, we already execute, and how are we going to put security test data or security test cases into the things we already run. And finally, I've got a couple of tools that I want to demonstrate and show you that are free and make a big difference in terms of your capability to execute security test cases, much the way that penetration testers and other security testers are already doing. So first, let's talk about security and user stories. Because when we start to think about what our software will do, that's a great time to think about security. And testers' jobs, by their very nature, are very much focused around user stories and what the stories say that the software will do, that the users will do, and so on. So, you know, your classic user story lines up something like this. And we have the typical structure of as a actor, I want to do a thing so that I can achieve a goal. And let me be the first to acknowledge that I know that this is a fairly simplistic description of a user story, and that in the real world, life is messier and it's not always as simplistic. I do feel that the security industry of which I'm a part tends to be a bit behind on software development methodologies and the way things actually get done. And so we pretty much fully embraced the waterfall about the time the software development industry left it behind. And so we're now adopting Agile, and we're all learning about how Agile software development gets done as the software development industry has been doing this for many, many years and is discovering the edge cases around it and refining the message. But let's work with this simplistic user story for the moment. And as we take a simple user story, I need to also warn you that these are my thoughts. These are things that I've been working on with my customers over the last few years, and some of these are rough thoughts and they're ideas and inspiration. Some of them are things I've done before, but I've only done it once, and so is it repeatable? Your mileage may vary. But these are interesting thoughts about getting security into the user story. So a standard story looks something like this. As a customer, I want to track my shipment so I know when it will arrive. That's a very basic sort of user story, and those things get elaborated out and turned into things that we actually build and test. Well, security stories could be written similarly. As a fraudster, I want to see the details of an order that's not my own, so I can go learn somebody else's private details. The inspiration for this comparison between user stories and security stories, hit me one day when I was buying online, and I'm paying for something. I have it in my trolley, and I think to myself, well, I'd like to pay for this with PayPal if I could. Shoot, they don't take PayPal. Okay, well, I'll give them a credit card. That's okay. They want to charge me £2 to use a credit card. Fine, I'll do it with my debit card. That's fine. Right, and I realize that as a user, you have a goal. I'm trying to buy something, and I have my favorite way of buying it, but it doesn't support my favorite way. So I fall back, and I try other things, and eventually I achieve my goal. Well, bad guys do the same thing. They think, ooh, here's a website full of juicy details. I want to get some customer data. I want to get credit card numbers. I want to get free merchandise. Let me try brute force guessing some passwords. Shoot, the website's got protections against that. Okay, let me try some cross-site scripting. That's not really getting it for me. Let me try some SQL injection. Oh, hey, there it is. I got it. Right, that's the mentality of bad guys as well. So in the same way that a good user trying to achieve a good result will try different avenues until they get there, so will the bad guys. Now, I have a couple of ideas about how we could write user stories that encapsulate security activities. One of them would be to sort of write the bad guys as actors in a user story. So there's a number of different bad guys that we could talk about. I'm doing a lot of work, like I said, with online retail these days, and so competitors are a potential bad guy. And you can imagine writing a security user story that says something along the lines of, as a competitor, I want to get a list of all products and prices so that I can make my own website sell at a better price. So you can imagine writing a security user story that encapsulates what a bad guy is trying to do to you, and then we can write tests that, and this is the controversial bit, tests that thwart the user story, that sort of show that that user story cannot be accomplished. That's one way to do it. As a criminal, I want to submit an order bypassing the payment step. Or as a criminal, I want to get the details of someone else's payment so that I can use those details to buy things for myself. As a disgruntled employee, I want to cause some damage to my former employer's brand. So I'm going to put nasty things on their website. These are all possible security user stories that we could be working into user story that we'll address with a test case. Here's an example. We're going to take a bad guy user story as a criminal. I want to see the details of an order that's not mine so I can learn private information of another person. Now we're going to create a test case that's going to try to encapsulate, well, what happens with our bad guy here? Given the user's logged in, they've got a valid session, they're going to make a request for an order that doesn't correspond to the logged in user. And so what are we looking for? Well, when that happens, display the error message, and potentially these are things that some folks will do. Well, let's also log that session out. Something bad's happened here. Log them out, make them log back in. And let's put some error in the application log or notify the operations folks. And so you may be looking at this and saying, well, yeah, that's a great idea, but I don't know how to be logged in as one user and request the order of another user. Great. I'm glad. Now we're going to have to go figure out how to do that. Right. If we write a bad guy user story, that means we're going to have to write some test cases around it. And that may, in fact, prompt our testers to go learn how to do some things that they hadn't done before. So, and when we get later on to some of the tools and techniques, I'll show you, one potential way of doing this. And I think that's the important idea here, is that once we start thinking about what the bad guys want to do, and we start thinking, well, how can we act like bad guys? And how can we write these test cases that emulate bad guys? How can we carry those out? There's a second feature to writing a bad guy user story like this that I really like, and that is the concrete action we're looking for here. We're looking for an error message. Now, I don't know about your particular situation, but in most of my clients, when an error message is going to go up on the screen, or there's some kind of error condition that the user will find themselves in, the business gets involved in saying, what does that experience look like to the user? Are they going? What are the words that they will see? What's the state of their session? Do they have a go back button? Do they get logged out? Do they have a retry? What do we do? So the great thing about a bad guy user story is that we're going to actually prompt the business to think about, what do we do in this situation? And what would you like that error message to say? And what would you like the state of that session to be when this obviously bad thing has happened? And again, I think that's going to prompt more security activities early in the life cycle that will actually help us contemplate and specify more interesting security situations. How will the software behave? So that's one way of doing kind of security user stories. We talk about the bad guys, and we talk about what the bad guys want to do, and we talk about how we respond to bad guys trying to do bad things. The other way to do this will be to write some good guy security user stories, where we contemplate folks who are related to the software and who are users of our software, but perhaps not the sort of first class, most important user we can think of. Again, with the example of online retail, obviously our first class users are folks like the actual customers buying things. But there may be some other important users who we can think of, and we can stipulate what they're going to experience. You may very well already have use cases like this. Things like, a fraud analyst needs a list of transactions that have happened and needs the ability to either filter them or screen them for certain attributes, that kind of thing. A customer service representative needs to validate the person on the other end of the phone or the person on the other end of an online chat session and ensure that they're actually the person he's supposed to be talking to before going on to reveal any important details. So by writing stories about these good guys and thinking about the goals that they're trying to achieve, we also can get the business to contemplate security situations and how they would like to handle them, and we can produce concrete outcomes that are testable. So we can start to write testable, we write test cases around, well, show me that we're able to do this. A couple of example good guy user stories, that we can start with. As a security analyst, I need to see sessions that have unusual characteristics so I can identify and terminate, bot and fraud sessions. I'll tell you an example from online retail. When you put something in your trolley in an online shopping site, very often the site will reserve a bit of stock for you, and each site does things slightly differently. Some of it's kind of a very soft reservation. If you've bought tickets to a theater show online, you understand that it's a very hard reservation, but at the same time they put some pretty strict time limits on how long you can kind of hold those tickets in your trolley without paying for them. And so there's always this sort of reservation thing that's going on, and a potential attack, of course, is to fire up a bunch of bots and have them all put 500 pairs of socks into their trolley, and the next thing you know, your website has no socks for sale because there's 500 bots who are holding all the socks in their trolleys and have no intention of ever buying them. This could be very disruptive to an online retailer. And this is the kind of thing that's contemplated as we write a good guy user story about seeing a list of unusual sessions and potentially interacting with them. Or imagining some web service online that allows users to have some device associated with their account, managing those devices. These are the sorts of security user stories that create testable situations. I suspect the good guy user stories are much closer to home and much more likely to be things you're already doing, whereas the bad guy user stories are a bit weirder because we're either contemplating something we don't want to happen, and so we're testing that it doesn't happen, or we're sort of writing positive test cases for negative outcomes, and that's the one that's a bit weirder. Fundamentally, if we're doing this, if we're creating security user stories, it's really important that we have an important actor. Now, I'm a big fan of OWASP, the Open Web Application Security Project, OWASP. And they've got a lot of great resources. I'm going to mention them later. But one resource that's not so great was an attempt they made to write security user stories. And many of their security user stories were things like, as a developer, I want to write good code so I don't get fired. I mean, it wasn't really like that. But, the user in the user story was like the developer themselves. As a developer, I want to write secure code kind of thing. And that's going to make a terrible security user story. That never gets prioritized into a sprint. It's not even actionable. So it's important that we write user stories that focus on people we care about. And sometimes the bad guys are, in fact, people that we care about. And we need to identify some sort of action or activity that's going to have a tangible output. And that's, again, why I love the error message concept. If you say, when a bad guy tries this, they're going to see an error, right? What should they see? When we had to deal with an online retailer recently who's allowing anonymous shoppers, so you don't have to already be signed in, you don't have to have a logged in account. You can put stuff in your trolley, you can go to the payment page, you can give your payment details and buy without logging in. And one of the things we contemplated was the stock reservation problem. And so we say to them, well, you're not going to allow these anonymous users to reserve stock, so what error message do they see when you are actually out of stock? Because you let them get all the way to the payment page without ever reserving the stock. That can happen. They get to the payment page, they go to pay, and actually, I'm sorry, there's nothing there for you anymore. And so by contemplating some of these error messages, that's a great way to hook in the business and get them to contemplate security impacts of how our software behaves. And then, of course, the test cases write themselves at that point. We have to make that error appear. We're going to make the software react. what's our test case that makes the error show up in the right time and never makes the error show up at the wrong time. So that's the first section I wanted to cover, this concept about how we talk about security in user stories, and we talk about security during the inception and the user story phase there. Now we're going to think about how we do our work and how do we stick some security test data into the test cases we already have. If you have experienced some kind of security testing in the past, you've probably experienced some sort of penetration testing, especially of the network penetration testing variety, which I think is pretty low value when it comes to software and software security. We're looking at things like network ports and protocols, and you're looking at the operating system level and the framework level. And while it is interesting to know that, oh, we're working on some version of WebSphere that has a vulnerability, those of us who are listening to this webinar are presumably working at a higher level at the application itself and its own business logic. And so a network level penetration test is turning in results that we don't really have a lot of influence over. So web security testing then, what we're talking about today is looking at the business logic itself, the bits that we are writing, that we're in control of, that we're responsible for testing, and figuring out what's happening there. We will focus on things the business cares about, like brand and reputation damage. Can the web app be defaced, or transaction throughput? Can we slow this thing down to the point that it's no longer meeting its agreed throughputs and the things that we need done? Can we cause it to corrupt transactions? These are things that we care about at a business logic level, and that's the web security testing we're talking about here, which is far more sophisticated than sort of spraying packets across a network and seeing what happens. And one of the things I've realized in my years of experience with software testers is that folks who do functional and non-functional testing day in and day out, if you talk to anybody in this industry, you know that they have things like coverage metrics. They go around and look at how much of the software do we cover with our tests. And you ask a security tester the same thing, and they don't even have a means of measuring how much they cover, much less are they going to produce an impressive number. And that's when it sort of hit me that, for every function that software is supposed to do, there's a tester out there who has test data and scripts and evaluation criteria for, did we do it right? Imagine the online retail case. Customer buys a product, they pay for it. Product gets shipped and delivered correctly. Customer decides they don't want it. They ship it back. Again, doing everything correctly and normally. Time to refund the customer, and the reversal to the customer's card, for whatever reason, is rejected. So now the customer has to enter in new card details, and now we start doing security testing. Now we start looking for ways to explore malicious things that could happen. That's something testers can do easily. That's something that security penetration testers frequently would never get that far. And so that's what the idea here in the second section is, let's look at the test cases we already have and see, could we get some security test data into things that we already have? Let me pose a hypothetical app for you. Imagine it's a web app that's going to let you look at your mobile phone minutes. Let's say you have 3 phones, they're sharing 1,000 minutes. And the way this particular form is going to let you work, you have to allocate minutes to each line. You've got 3 lines. And the 3 examples on the right are all sort of valid. You could have 250 minutes for line 1 and 250 minutes for line 2, 500 for line 3, that's fine. The rules are pretty simple. Non-negative integer, it's got to sum to exactly 1,000, can't leave any on the table. 0 is perfectly valid. You could have no minutes allocated to one line and 1,000 allocated to another. So this is our example scenario, and if we do sort of testing 101, right, we know about boundary values. We know about, we're going to use -1 and 0 and 1 and so on. And if we were interested, we might go on and say, you know, I actually know that we're using Java, and so they're probably signed integers on the back end, and so let's go figure out what maxint and minint for signed integers at 32-bit data types are. And you could throw those in as well. The other thing we see a lot with in software testing is the concept of equivalence class partitioning. We can't test every possible bad input, but we can break possible bad inputs into equivalence classes, and then we could do a few test cases from each class. All right, so let's throw in some alphabetic letters in there. They shouldn't work. Let's make sure we get an error when that happens. We might try things like character sets and encodings that are unexpected, and just, again, make sure that when those things get down to the server, it actually rejects them correctly. And you could even leave things out. You could send null values or just omit parameters entirely and make sure that things work correctly. And this is all, again, standard testing. This is not doing the security testing yet. And my concept here, and what I think we need to start doing, is just there's a new equivalence class. In addition to things like, you know, funny character sets and you know, non-numeric input, well, we've got security equivalence classes. So if we've got some test data for some of these input fields, like, you know, -1, well, what about putting some SQL injection strings in there? The kinds of test cases that will, in fact, trigger some strange error out of the application. Or ideally, you know, from our perspective, a pass would be, hey, we're sorry, that's not valid input. But if you get, you know, a database error, that's kind of a bad problem. Likewise, from a cross-site scripting perspective, you know, you can send in various HTML, JSON, XML, send in whatever sorts of inputs. And if you get a bad response, then you know, okay, that's no good. We're vulnerable to one of these headline vulnerabilities. If you know that it's processing XML on the back end, then you want to try and send, you know, XML values here and see if they end up being treated the wrong way at the back end. And so these are all basic kinds of test case data that we can just start adding to our regular test cases, to the test cases we already have. And this is where I'm trying to connect security testing back to the example I gave a minute ago, where you try to refund to a card, the card's denied, and then the user enters some details about a new card. Well, great. At that point, throw some of this stuff in. Because I'll bet you that the penetration testers who test your apps don't get that far down, but you, the functional tester, get that far down routinely all the time. And so you can pick a lot of low-hanging fruit and find things that may not be findable otherwise because of the test data and the test scripts that you have. You may say, well, hey, that sounds like a great idea, Paco, but where am I going to get test data for that sort of thing? I'm not a security specialist, remember? Right, you are correct there. This is one of the things that OWASP offers that's actually quite good. You know, their cross-site scripting, you know, filter evasion cheat sheet. So you're trying to evade cross-site scripting filters, trying to evade developers who are trying to do it right. That's a list of all sorts of cross-site scripting strings that you could then mix and match and add to your test cases to see if you're vulnerable to cross-site scripting. Likewise, from a injection perspective, you can get an awful lot of test cases from something like SQL Ninja or SQL Map, which are free tools that you can go use to poke at a web app, poke at a database through its corresponding web app. And I'll tell you one thing that I think is an interesting way to do this. Many of us have penetration testers come test our web apps. And if it were me, if I was the head of testing on that, I would turn all the logging to 11 in my test environment when the security testers came in, and I would capture every test case they threw at me. And then I would hand it over to one of my testers, and I'd say, you know what, see all those inputs that they were sending? Let's capture some of those, and let's try those and add those to our standard regression suite. So the next time that they come in, we've already tested a lot of this stuff. especially if the penetration testers turn in a positive result and say, oh, actually there's a problem here. Well, great. If they actually turn something in, we should make it part of our regression tests so they never get to turn that one in again. I don't think a penetration tester should ever turn in the same result twice. And so what I want to do now, having given you this idea that, okay, we could stipulate security tests in the user stories, and we could decide to take security test data that's already out there and put it into our own running environment. We've already got these test cases. Let's just get some security test data in there. Well, let's talk about a couple of tools that can do this for you. How would you actually do it hands-on? And I only have time to discuss two tools that I really like. One of them is Firebug, and the other is Burp. But it's worth mentioning Selenium. If you're already doing web security testing, then you probably almost certainly are using Selenium, which is another reason I'm not going to sort of explain it at some remedial level. Here's what it does. Well, one of the great things I love about Selenium is that it takes test cases as basically HTML. I mean, they're basically text files because they're in HTML. Which means that if you have interesting test cases already written out in Selenium, you have this, bucket full of HTML files that are your test cases. Well, it's easy to take one of those and then just do variations on it with security test data. That's a great way to automate security test cases. But I'm going to show you a couple of tools that we in the security testing business use all day long. They're free and they're easy for you to use as well. And the first one is Firebug. So if you're using Firefox, you can get this add-on that will give you a live view of the DOM. Now the DOM, if you're not familiar with the web and how web browsers render, the DOM is the document to object model, and this is what your browser thinks is going on in there. The HTML of the web page is kind of the starting point for the DOM, but then JavaScript and CSS and all these other technologies that are running inside the browser can manipulate the DOM and change it. So looking at the source of HTML is a useful place to start, but it doesn't really capture what's going on inside the app itself. And there's a number of things that you can end up doing with Firebug that bypass or change the way the client works. Now, I can't give you a demo of a live website that's going to embarrass anybody, so I'm going to have to give you a fairly innocuous one. Let me show you what it looks like in Firefox. So we're looking at Kelley Blue Book. This is just a website I sort of picked at random. I often use it because I'm going to show you how this works, and it's no embarrassment to them. There's nothing really wrong with their website. I'm going to tell you can imagine some things that do go wrong this way. So this is the website. What's my car worth? That's fine. And if I open up Firebug, now I have this little tool along the side here that's showing me how the DOM actually looks inside my web browser. If I looked at the source code of this web page, I would not see the same thing. It actually changes dynamically. Now, one of the things that you notice is you have like this year, make, and model drop down. You notice that the make and model are deactivated. You can't interact with them. But that's just an HTML attribute. And I can come over here and say, hey, Firebug, show me, where is the HTML in the DOM for the particular thing that's under my mouse right now. To do a trivial example, I can take that title there and say, get your Paco value, and there it is, right? That's an absolutely local change. It's not, I haven't edited the website itself. It's not affecting anyone but me right here on my laptop. But this is the kind of thing that we can do. And in particular, I can come down to one of these input fields like this one here, and you can see that it's disabled, and it's not going to let me interact with it. But there's the attribute right there that says disabled. Okay, fine. I mean, if we change that to say foo instead of disabled, and now this thing is enabled, and I can start doing things. The reason this doesn't give us any advantage on the Kelley Blue Book website is because, you know, they programmatically fill out that drop down. I pick a year, and suddenly, you know, now I can pick some makes. But I have known websites, and I more than you'd like to believe, where they're showing you, for example, all of your details: your name, your address, your phone number, your date of birth. And from that website's perspective, your name and your date of birth don't change. So they don't give you the ability to edit those things. And what ends up happening is the only thing they're doing to stop you from editing is they're putting this disabled equal true or disabled something into the website, into the HTML. And as soon as you take away that disabled attribute, it becomes editable. And I have literally, you know, changed my name, changed my birth date, changed things I shouldn't change on websites by doing nothing more than this little trick. And there you go. There's your clickbait title, you know, change data on websites with this one weird trick. So this as a tool is incredibly powerful because it lets you change what's going on inside the web browser and bypass things that are happening in the web browser to protect you, that are part of the security of the website. You can also use this to post. You can invoke JavaScript. There's a JavaScript console that you can make this bigger, and there's a JavaScript console, and you can actually see the JavaScript in the web pages. You can type on this line down here and actually invoke a JavaScript function live. So if there's a JavaScript function that says submit my page, well, you could type submit my page right here, and it'll run it, even though the user didn't click. You can get some interesting results that way. So this is a tool that I get a lot of mileage out of. The second tool that's really valuable for testing is to use a proxy. And proxies have existed since the very, very first days of the web, and they have some very important legitimate uses. A proxy will sit between your browser and the actual web server. And we do this all the time for legitimate reasons. There are reverse proxies that sit between the server and the browsers for purposes of like caching or load balancing. Or there are proxies that a company might run because they want to look at what's coming down to web browsers. Does it contain malware? Does it contain anything malicious? There are legitimate reasons to have proxies. But the fact of the matter is, the proxy is literally a man in the middle. It sits between the browser and the website, and it lets you examine what's going on between them. And it can even do it from the perspective of SSL, TLS. You can do this on encrypted connections too. It's running on your system, sitting between your browser and the rest of the world. There's one that we all use in the security world, and there's a free version of it as well as a commercial version. It's called Burp. And you run it on your computer, and then you tell your web browser, hey, route all the traffic through this proxy. Or you can say, route all traffic for this particular domain through this proxy. So if you have some test domain that you're testing, you can have all that stuff going through the proxy and nothing else. So your standard web pages and Googling and whatnot are not going through the proxy. So given a proxy like that, you get the opportunity to interact with the things between the time that you click in the browser and the time it actually arrives at its destination at the server. So this is an example, just a screen capture showing that the proxy lets you see what's going on, and you can see the login, the username, the password. You can see all these things. going across the wire, and you can potentially intercept and interact with them. As a request goes by, you can actually look at every bit of that request, every parameter, every value, and make changes to it. And I'll sort of show you what's going on by showing you Burp in action. What you're now seeing is the Burp interface, which is a separate it's a separate window to my web browser. And while you can't see my web browser, if I click on some other link, you see it come through, and everything that's going on is showing up in this proxy. And we even have an indicator here. We have an indicator that shows me, oh, this had some parameters to it. And so I can go down and I can see, what the parameters were, and I could have stopped any one of these requests, and I could have looked at the parameters and changed the output. So this kind of activity means that whatever the web browser was going to do, client-side JavaScript, checking for a valid postcode, checking for a strong password, checking for whatever, all that happens. Then the request gets transmitted towards the server, and that's when Burp picks it up and says, hey, would you like to change that? And in fact, I can. I can turn intercept on, and then when I choose something on the website, like I pick a year, here comes a request through. And now I can see this request. It has left my browser but has not made it to the server yet. And I can make changes to it. I can send it off to the intruder, who will then look at different places to attack it, and so on. Or I can turn intercept off and just let all the requests go through. And then I can look at them later and say, okay, so what was this about? So that's an example of a tool, Burp, and you have to understand it's a very complicated tool, and it's used by lots and lots of security folks for lots of good security reasons. It's also free, and there's a fair number of results that are coming to you from your penetration testers that are little more than pointing Burp at the website and seeing what it turns in. So if we were to do this as software testers, then we would make them work harder to turn in more interesting and sophisticated results. And I think that's a good thing for everybody. And while this is not a webinar about mobile security testing, it's worth knowing that this whole proxy process actually does work on mobile as well. So if your mobile phone is connected to the same Wi-Fi network, or your iPad or your tablet, if it's connected to the same Wi-Fi network that your laptop or your desktop system is connected to, if they're on the same network, then you can make the mobile device route all of its requests through your laptop, through the Burp proxy, and you can tamper with some as they go by. Again, assuming you have sanity checks going on in a mobile device, you can bypass some of them because the request has left the mobile and has stopped at the proxy, giving you a chance to make changes and make inputs that the client itself would never allow. So the whole proxy concept is hugely important both in the web and in mobile, and in virtually anything that has HTTP. This is a standard testing methodology. The last sophisticated concept I'll leave you with that's too much to talk about at any one in this context is tampering with the responses. I have definitely seen a situation or two in my career where the client-side JavaScript was so complicated that what was being transmitted from the browser to the server was just beyond my ability to manipulate, and I couldn't understand the requests. They were encrypted or they were protected too carefully. Hey, good on you. But the reply from the server would come back in something nice and easy to understand, like JSON or XML. And by making changes to the server's response, I changed what the client thought the current state of the world was. So, for example, I had one that was a file browsing sort of web app, and I couldn't make it generate a delete request for a file that I didn't own. I tried and I couldn't get it to do that. But then I watched the responses. When you do a file listing, the response comes back from the server in XML. And I changed some file IDs, ID numbers of some of the files that were being displayed in my web browser. And then when I clicked delete, it generated a delete request for a file ID that wasn't mine, and in fact it worked. So the really interesting idea there is to tamper with the responses, not just the transmissions from the browser. So this sort of brings us around to the end here. The biggest takeaway message for security testing is, of course, that everyone who has something to do with software, whether they're writing user stories, they're doing architecture and design, code, testing, whatever they're doing, they have something to do with software security. Security is done by the people who build the software, not by the security people. Software security is done by people who don't have security in their job title. So what I discussed today was, user stories that let us describe security behavior in a couple of different ways, either by hypothesizing the bad guy as our user and writing out what they're trying to do, or hypothesizing a good guy who wants to do something security related, and then giving us test cases, perhaps centered around error messages, that let us prove we're doing the right thing. In terms of taking our standard functional tests that we already have, taking these test cases, we can get data from projects online like OWASP or free tools, or even penetration test results that have already been turned in on our project, and add that security test data to the test cases we already have. And then this proxy as a mechanism to intercept and modify communication is vitally important, because it's how we bypass a lot of checks that go into delivering into the way our software runs. So, of course, my name is Hope, and that means that I am fundamentally an optimist. And I always conclude with this quote: "The best time to plant an oak tree, well, yeah, it was 20 years ago. If you did it then, you'd have a 20-year-old oak tree right now. But the next best time to plant an oak tree is right now." So the best time to secure our software, well, yeah, it's back when they were planning the first version, when they were building the architecture, when they were doing the designs, of course. But the next best time to secure our software is right now. And we shouldn't be afraid to do incremental changes and improvements on our security just because we didn't get there at the very beginning. Lastly, I'll call your attention to my email address and my Twitter handle. There's a lot of security conversations happening on Twitter. I follow a lot of interesting people, and I make commentary on, interesting security techniques, interesting security developments. If security is something that you're interested in, Twitter is a really great place to meet. And I also know that most of my fellow speakers at EuroSTAR are all out there on Twitter as well, having some really interesting conversations. So I would encourage you to sign up, to follow some of us, and join in the conversation. With that, if you have questions that you'd like me to answer, things you'd like me to elaborate on, hopefully you've sent those in, and I'm going to hand it back to Dara now and answer whatever questions come up.
Thank you very much, Paco, for that. It was really, really interesting, and I can see there's a lot of our attendees still hanging around, hanging on every word, so it's been really great. And if you'd like to hear more from Paco, he will be keynoting at the EuroSTAR conference next week. His keynote is on Wild West security, and he'll also be doing a tutorial on the fundamentals of software testing web applications. You can register for the conference over on the EuroSTAR conference website, and if you register 4 attendees, you'll get a 5th place absolutely free. This year as well, we'll be running a new conference on the Friday after EuroSTAR, and this will be called Mobile Deep Dive, which is a mobile-focused conference, and you can find out more information about that also over on the EuroSTAR conference website. So now let's have a look and see what questions you have. So if you have any questions, please type them in. I have a question here, Paco, that asks, when people talk about security, all they talk about is web-based applications. What are the risks for client-server applications?
Oh, that's a great question. A lot of the things that I have seen from client-server-based applications is an assumption that because I've written a binary client, the user cannot sort of interfere with the client's behavior. And I've seen a lot of security assumptions around the integrity of the client not making requests that should be denied. I've even seen some applications go so far as to do authorization enforcement in the thick client. So the binary logs you in, figures out what role you're supposed to have, and only presents the right options to you based on what role it knows you have. And if you were to tamper with that client and tell it that you have a higher privilege role, then the client will gladly make higher privilege requests for you, and in fact will then, and the server doesn't reject those because the authorization enforcement is done in the client. So, and the mobile really qualifies in that way a bit too, because many people think that there's such integrity of mobile apps that users can't tamper with the behavior of a mobile app, that they count on the mobile app executing correctly, and we've seen some mobile apps also make decisions that are security relevant when they really shouldn't.
I don't see any other questions just at the moment. So if you have any questions, we'll take them now. Just while we're waiting there as well, I'm just going to make you aware that we have a webinar series coming up in December on test automation. We'll have 3 speakers there. That'll be Kim Herzig, Jared Richardson, and Dorothy Graham. And I'm just going to share a link with you there. It's testhuddle.com/test automation if you'd like to find out any more about this series. So I can see there's a question there, Paco, that says any other tool other than OWSAP?
Well, sure. I mean, of course, there are lots and lots of tools. It depends on your domain and what you're trying to accomplish. So I really did focus on the web in this particular one. It's valuable, for instance, if you're doing mobile, there are simulators. Of course, there's the Android simulator and there are iOS simulators, which can give you a great deal of test capabilities, such as spoofing GPS inputs so that you tell the device that it's somewhere in the middle of the ocean or in a geographic area that it shouldn't be. There are lots of test tools like that. And I put on the slides, though I didn't talk about it extensively, a particular Linux distribution called Kelley, K-A-L-I, Kelley Linux. And it's basically Linux with a ton of security tools baked into it. So they're already installed, they're already configured in a reasonable default way. And that too is one of these Swiss Army knives that every security tester has on their laptop somewhere. And if you're trying to, if you read about some security testing technique and you're sure that there's some common hacker tool out there to do it, you know what, it's probably in the Kelley Linux distribution. Just go get that and look to see if it's installed there. It probably is. And it saves you the trouble of trying to install and understand some specific tool. You can just go get one Linux VM that has all of them in it.
I think, Paco, we'll leave it at that. We've gone over the hour, and I just want to thank you again for your webinar today.
Great.
And thank all of our attendees for taking time out of their day to attend this webinar. And looking forward to catching up with you next week, Paco, at the EuroSTAR conference over in Maastricht. And there's a recording.
Thank you very much.
You're welcome. And there's a recording of this webinar over on Test Huddle, and you can check that out now very shortly. I'll just add the recording. So that's it for today. Thank you very much, and take care.